In this video, we're going to solve inequalities with absolute value. Now, before we solve our inequalities, let's solve very simple inequality. Something like absolute value of x greater than or equal to k. K is a positive number. Now, let's look at this into the number line. So this is 0. This is k. This is negative k. Now, from 0 to k, the distance is k. From 0 to negative k, the distance again is k. Now, we're looking for absolute value of x. Remember, the absolute value of x is the distance from 0 to x. So if we want the absolute value of x, which is the distance from 0 to x, to be bigger than k, x must be here or here. Because here the distance is greater than k, this is k, here it's greater. And also here the distance is greater than k because this is k. Hence, we now can write that solving this inequality is the same thing as solving the inequalities x greater than or equal to k or x less than or equal to negative k. So this is the most important part here. Now let's go to our inequality. Part A, inequality is given 2 times absolute value negative 2x plus 3 minus 1 greater than or equal to 1. Now we add plus 1 here, plus 1 here. Remember, what we are trying to do is to isolate this absolute value. So we add 1 and 1. That gives me 2 negative 2x plus 3. Now here we have negative 1 plus 1, 0. And the other side gives me 2. Now we divide by 2 the two sides of the inequality. Dividing by 2, which is a positive number, there is no need to change the symbol of inequality. So 2 and 2 gives me 1, negative 2x plus 3 greater than or equal to 1. Now we use this idea to say that solving this or solving the two inequalities without absolute value. So solving the inequality with the absolute value is equivalent to solving the inequality this or we have used this idea here. The only difference is instead of having x, we have an expression. And now we go and solve the inequalities, the two of them here, this one, and then we take the union because of the or. So equation inequality number 1, negative 2x plus 3 greater than or equal to 1. Subtract 3 from both sides. So this minus 3, this minus 3, this gives me 0, and the other side will be equal to minus 2, negative 2. And then we divide both sides of the inequality by negative 2. When we divide or multiply the two sides of an inequality by negative number, we switch the inequality symbol and then simplify now, and that gives me x less than or equal to 1. We go here, 2, we solve now this inequality, so this was 1, this is 2, so negative 2x plus 3 less than or equal to negative 1, so negative 3, that gives me negative 2x. This gives me 0, and then less than or equal to negative 4. Divide the two sides, so negative 2x because again I am dividing by -2, I need to switch the symbol of inequality, and that gives me x greater than or equal to 2. Remember, there is an or, therefore, yeah, you can write the solution as is written here, x less than or equal to 1 or x greater than or equal to 2, or using the intervals. This gives me this union plus infinity. Now let's go and solve. Now the inequality in part B is given by absolute value of x plus 4 minus 2 less than or equal to 2. Now let's go here to the number line and try to solve a very simple inequality with absolute value less than or equal to k. Now this is k, this is -k. Now this distance here is equal to k, this distance here is equal to k. We want the absolute value of x, which is the distance from 0 to x, to be less than this distance. So my x must be somewhere here for the positive values of x, and my x must be somewhere here for the negative values of x, which means this inequality with absolute value is equivalent to the double inequality and this is the most important thing to understand using the number line. Good, now let's go to our inequality and let's isolate the absolute value by adding 2 to both sides. Yeah, we add 2 here, we add 2 here. This gives me 0, so that x plus 4 less than or equal to 4. Now I'm going to use this idea, the only difference between this equation, this inequality, sorry, and this inequality is here, we have x plus 4 instead of the x, and here 4 instead of the k. So I can write my inequality with the absolute value as a double inequality without absolute value, as we have shown here. Good, now we need x, so we need to subtract 4, 4, and then 4, and that gives me -8, x here less than or equal to 0. This is the solution of the inequality, and in interval form, closed -8 to closed 0. So the most important things to retain from this video are the following. An inequality of this form can be written or is equivalent to an inequality of this form without absolute value. And the second point is an inequality with absolute value of this form less than or equal to k can be written as a double inequality. Now, there is nothing to memorize here. Just retain the explanation with the number line in both cases and you should be okay.